Okay, get this. Today we're diving into AI that can actually do machine learning research.
Like actual research, not just, writing code, but doing the whole scientific thing.
Yeah, think scientists, but AI. Crazy, right?
Totally. And the paper we're looking at basically lays out this framework they're calling MLGym.
MLGym.
Yep, to test how well these AI research agents perform.
So it's a giant obstacle course for AI, but for like science.
Kind of. I love that analogy.
And, this paper doesn't hold back at all. It talks about everything from like, basic AI experiments all the way to
AI making Nobel Prize-worthy discoveries.
Whoa. Hold on. Nobel Prize AI, seriously.
That's what they're saying. It's kind of mind-blowing. So they have these like capability levels, right?
Okay.
And level 0 is basically like, your average science fair project. The AI is just recreating something we already know.
Got it. Like entry-level stuff.
Right. But then level 1 is where things get really, really interesting.
Okay, what happens at level 1?
Level 1 is all about improvement. Like the AI has to actually take existing work and make it better, not just copy, but actually improve it. And that's where this whole MLGym-Bench thing really focuses.
Okay, so back up a sec. How does MLGym actually work? Is it like a virtual lab for these AI agents?
Exactly. It gives the AI access to code, data, all the tools they need to do experiments.
So it's like I'm picturing like an AI with a little lab coat on doing experiments in this virtual world.
Haha. Yeah, pretty much. Like imagine one of these agents is trying to improve the accuracy of an image classification model.
Okay.
It can actually like tweak the code, test it on data, all within this MLGym environment.
So it's not just coming up with ideas, it's actually like rigorously testing them, like an actual scientist.
Right, and that's what makes this research so compelling. It's not just theory. They're actually building these systems and seeing what they can do.
All right, so back to MLGym-Bench. What kind of like research challenges are these AI agents up against? What are they actually doing?
So they have 13 different tasks in MLGym-Bench, and they span like a surprisingly wide range of stuff. So some involve classic games, like Prisoner's Dilemma.
Ooh, Prisoner's Dilemma, that's a good one.
Right. But the AI has to actually write the code for its strategy.
Wait, so it's not just choosing like cooperate or defect, it's like writing the algorithm to play the game.
Exactly. And then there are tasks that involve optimizing a SAT solver.
A SAT solver?
Which is like this logic problem that even humans find pretty tricky.
Okay, got it.
And then, of course, there's, the classic machine learning stuff like training a language model on a huge data set.
So like a greatest hits of all the major machine learning challengers.
Pretty much, yeah. And the cool thing is that MLGym is designed to be open-ended. So researchers can add new tasks and tools as the field kind of, progresses.
So it's not just a static benchmark, it's like a living, breathing, like platform.
Yeah, exactly. It's a fantastic way to track the progress of these agents and see how they stack up against each other.
Speaking of which, this paper puts some of the like biggest names in AI to the test. They've got Claude, Llama, GPT-4, all the heavy hitters. So what did they find?
Yeah, so they actually found that these models can really improve on existing baselines. Like they're really good at tweaking hyperparameters, for example.
They're not just like blindly stumbling around. They're making like intelligent adjustments.
Right.
But are they coming up with like genuinely new ideas?
Not yet. And the paper uses this really clever metric to figure that out. It's called the AEP score. And it's borrowed from like the world of optimization research.
Ooh, optimization. That's interesting. So how does this AUP score work?
Okay, so imagine you're plotting how well each model does on each task, right? Instead of just looking at like who wins each task, this score looks at how consistently each model performs well across the board. So it's like a measure of overall competence, not just like, isolated brilliance.
Gotcha. So it's like a decathlon for AI research agents.
Yeah, exactly. Like you need to be good at a bunch of different things, not just a specialist in one area.
I like it.
And based on this AUP score, OpenAI's model, came out on top. But Gemini was right up there with it and actually struck a really impressive balance between performance and cost.
Oh, interesting. So like if you're on a tighter budget, maybe Gemini's your go-to?
Yeah, or if efficiency is like a key factor for you, then maybe Gemini makes more sense.
Cool.
And it's important to remember, this whole ranking is just a snapshot in time, right? As new tasks get added and these models keep evolving, that leaderboard could totally change.
The race is on.
Totally.
Okay, so this is where I get super curious, right? Beyond just like the scores, what can we learn about how these AI agents are actually doing research? Are they like mimicking the way human scientists work?
Yeah, that's one of the coolest things about this paper. They didn't just look at the results. They actually analyzed the actions these agents were taking within MLGym.
Ooh, okay.
And what they found is that the agents actually spent a lot of time editing and viewing code.
Oh, so they're not just like spitting out answers. They're like tinkering. They're trying different things.
Exactly, yeah. It really suggests that they're engaging in this like iterative process, just like human researchers.
So not just the eureka moment, but the actual like grunt work.
Totally.
That's fascinating. So it's not just about building AI that can solve problems, it's about building AI that can like think like a scientist.
Absolutely. And that's really where things start to get even more interesting.
Okay, so let's talk about that because I'm ready to get into the more sci-fi sounding stuff.
All right, let's do it. All right, so we left off talking about these AI agents that can actually make like genuine scientific contributions.
Right, the ones that go beyond just like tweaking and start really pushing the boundaries.
Exactly. And level two is where it gets really interesting because that's where the AI isn't just improving on what's already there, but like coming up with completely new solutions that could even outperform, the best human efforts.
Okay, now we're talking. So give me an example. Like, what would a level 2 AI research agent actually look like in action?
So imagine you give an AI agent, right, a research paper that outlines a problem, say, improving the efficiency of a specific algorithm.
Okay.
Now, instead of just trying to, fine-tune that existing algorithm, a level 2 agent could actually analyze the problem from, like, first principles and potentially design a totally new algorithm that's, like, way more efficient, way more robust, something that humans might never even think of.
Okay, so it's not just optimization at that point. It's like genuine innovation.
Exactly, like coming up with new ideas, and that's what really sets level 2 apart from the lower levels. It's the point where AI starts to transition from being a tool to being like a collaborator, a scientific peer.
Wow, that's a pretty big shift, but like, are we even close to achieving that kind of AI? Did any of the models in this paper even reach level 2?
Not quite, and the researchers are very upfront about that. Even the most advanced models they tested are still primarily operating at level 1. They're great at optimization, but they haven't really demonstrated that ability to generate like truly groundbreaking new ideas yet.
Okay, so level 2 is still like a goal for the future.
It is. But the paper does hint at like how we might get there.
Okay, I'm intrigued. How do we get there?
One of the key takeaways is this idea of open-endedness in the design of these AI agents and the environments they learn in.
Open-endedness. Okay, break that down for me a little bit.
So it's all about giving the AI agents more freedom to explore a wider range of possibilities. So instead of just like, giving them a specific task and a set of constraints, they need the space to like wander, to experiment, to maybe stumble upon like unexpected insights.
So instead of being like, here's the problem, find the solution, it's more like, hey, here's this whole area of research, go explore and see what you find.
Exactly. It's like the difference between giving someone a paint by numbers kit versus like, a blank canvas and a set of paints.
Ooh, I like that. Like, who knows what they might create, right?
Exactly. So then the question becomes, how do we actually create this open-endedness for AI research agents?
Yeah, is it just like give them more powerful computers and bigger data sets?
It's more nuanced than that. It's about designing environments that actually encourage that kind of exploration and experimentation. And that's where things like the memory module in MLGym come in.
Okay, memory module, what's that?
So think of it like a scientist's notebook, like a place where the AI can actually store and retrieve information, over longer periods of time.
So it's like remembering what they've learned before.
Exactly. And that allows them to build upon their past experiences, to maybe connect the dots between different experiments and, maybe stumble upon those like, moments that lead to breakthroughs.
So it's not just about like processing information in the moment, it's about reflecting on it and like drawing insights from it.
Exactly. It's a very human way of learning and discovering.
It is, and the paper actually gives some really cool examples, like, in the appendix where you can actually see the AI agents using this memory module to retrieve results from previous experiments and, like, actually use that to guide their current research. Wow, that's amazing.
It is, and it's a crucial step towards like achieving those higher levels of AI research capability, moving beyond just like brute force computation and towards something that resembles like genuine scientific intuition.
I'm starting to see why you're so excited about all this. This is pretty cool stuff.
It is. It really is. And that brings us to levels 3 and 4, where the AI agents start making contributions that go beyond just like incremental improvements.
So we're talking AI that's not just solving problems, but like identifying new problems, right?
Precisely. Imagine an AI agent that through its exploration and all this experimentation discovers a fundamental flaw in like a widely used machine learning algorithm.
Or maybe it comes up with a totally new way of thinking about a problem that leads to some major breakthrough.
Exactly. Those are the kind of contributions that, could push the boundaries of our scientific knowledge and potentially even have like a profound impact on society.
Okay, I'll admit it. I'm starting to get goosebumps here. This is like mind-blowing stuff.
It is. And it's important to remember this isn't just like speculation. The authors of this paper are, leading researchers in the field, and they've laid out a clear roadmap for how we might actually get to these higher levels of AI research capability.
So, like, if we follow this roadmap, what's the next big hurdle? What's standing between us and these level 2 AI research agents, the ones that can make those, genuine scientific contributions?
I think one of the biggest challenges is building AI agents that can not only explore, all these different possibilities, but also evaluate the novelty and the significance of their discoveries.
Right, because it's one thing to generate a bunch of random ideas, it's another to know which ones are actually worth pursuing.
Exactly, exactly. And that requires like a deeper understanding of the scientific process itself. It's about being able to distinguish between, just incremental improvements and truly groundbreaking insights.
It's almost like we need to teach these AI agents not just the content of science, but the philosophy of science, the principles that guide scientific inquiry.
Yes, you're getting it. And that's what makes this whole field so exciting. It's not just about pushing the boundaries of computer science, but it's about pushing the boundaries of our understanding of knowledge itself.
Okay, so we've talked about level 0, 1, 2, 3, 4. That leaves us with level 5, the summit, the holy grail.
The peak, where AI agents are not just collaborators, but like visionaries pursuing long-term research agendas that could lead to, paradigm-shifting discoveries.
So we're talking AI that could cure diseases, solve climate change, maybe even answer some of the fundamental questions about the universe.
I know it's tempting to get carried away with all the possibilities, but it's important to remember that level 5 is still very much, in the realm of speculation at this point.
But it's not impossible, right?
And that's the beauty of it. With every new breakthrough in AI, what once seemed impossible suddenly becomes a little bit more plausible.
Okay, my brain is officially fried. I need a minute to process all this.
Haha, I get it. It's a lot to take in. But, before we jump into the really, truly mind-bending possibilities of level 5, let's maybe zoom back in on what we've learned about how these AI agents are actually behaving. Right?
Yeah, good idea. Let's ground ourselves back in the reality of MLGym and what we can actually glean from these early experiments.
Absolutely. And one of the things that really jumped out at me was how much time the agents spend interacting with code.
Oh, yeah, you mentioned that earlier. They're not just passively looking at data, they're actively messing with the algorithms, right?
Right, exactly. And the paper actually goes into way more detail about this, highlighting the specific actions the agents are taking. Entering code, viewing code, compiling code, running code. It really paints a picture of this iterative process, very similar to how human programmers work.
So it's not just about having that brilliant flash of insight. It's about all the little steps, the trial and error, the constant refinement that actually turns that idea into a working solution.
Exactly, exactly. And this iterative approach is actually reflected not just in those code-related actions, but also in how the agents run and validate their experiments. They're constantly checking their results, making adjustments, and running things again. It's very much this hands-on experimental process.
So they're almost developing a scientific intuition, right? A sense of what works and what doesn't based on their experience.
That's a great way to put it. They're not just following a set of, pre-programmed instructions. They're learning from their mistakes, adapting their strategies, and kind of gradually honing their skills.
So it's not just about building AI that can solve problems. It's about building AI that can think like a scientist, that can engage in that kind of messy, iterative process of discovery.
Absolutely. And these insights into the agent's behavior are crucial for understanding, not just what they can do, but how they're doing it.
It's like peeking behind the curtain, seeing how the sausage is made.
Right. Exactly. And as we delve deeper into these higher capability levels, understanding these processes becomes even more important.
All right, well, I'm ready to delve deeper. Let's talk about those higher levels where things start to sound, a little bit more like science fiction.
All right, let's do it.
All right, so we're back, and things are about to get, seriously meta.
Meta is a good word for it. We're talking about AI that can not only design experiments, but design, entirely new AI.
So AI designing the AI that designs AI. Yeah, my brain hurts too.
It is pretty wild. But it's definitely a question we need to think about, right? If we want AI to become a true scientific partner, we have to consider that possibility. AI building AI.
I mean, yeah, but that kind of sounds, I don't know, dangerous. What if we create AI that's smarter than us and then it starts creating even smarter AI? Where does it all end?
It's a totally valid concern. And when the researchers address, right up front, they acknowledge those potential risks, especially the risk of AI capabilities accelerating faster than we can even understand them.
So they're not just let's see what happens. They're actually approaching this carefully.
Yeah, definitely. They argue that one of the main reasons for developing these frameworks like MLGym is to give us a way to actually observe and guide the development of these powerful tools. So we can see what's happening.
Like putting up some guardrails, making sure we have some control over this whole process.
Exactly. And by studying how these AI research agents behave in, these controlled environments like MLGym, we can hopefully spot any potential problems early on and figure out ways to mitigate the risks.
Okay, that makes sense. But I still have this I don't know, uneasy feeling about AI designing AI. It just feels so, I don't know, unsettling.
I get it. It's a big shift in how we think about intelligence, right? Both artificial and human. But it's important to remember that we're still in the super early stages here. Like the AI agents we have today are nowhere near being able to design systems that rival human intelligence.
So for now, it's more about exploring the possibilities than worry about some kind of AI takeover.
Yeah, exactly. And those possibilities are, pretty incredible. Like imagine AI that can design personalized learning algorithms, ones that adapt to each student's individual needs.
Or AI that can analyze huge amounts of medical data and discover new treatments for diseases.
It's really mind-blowing when you think about the potential benefits, but it's on us to make sure these powerful tools are being used for good.
Okay, so we've talked about the good, the bad, the potential benefits and risks. But what about the actual, nuts and bolts? How do you even start to build AI that can design other AI?
That's where things get really interesting, at least from a technical perspective. Honestly, we're still figuring a lot of it out. But one promising approach is to use something called meta-learning.
Meta-learning. Okay, now we're going full meta.
I know, right? But think of it as teaching an AI agent how to learn more effectively. So instead of just feeding it data, we're teaching it how to learn from data better.
So it's teaching a student how to study smarter, not just harder.
Exactly. And by applying these meta-learning techniques to AI design, we might be able to create AI agents that can actually learn to design new machine learning architectures, new algorithms, even whole new AI systems.
Wow. So we're talking about AI that can basically bootstrap its own intelligence, becoming more and more capable over time.
It's a bold idea, for sure, and there are definitely challenges. But the progress we've seen in AI research, just in the past few years, it really suggests that it might actually be possible.
It's exciting and a little terrifying all at the same time.
I agree. But that's kind of the nature of scientific exploration, right? We're pushing into uncharted territory, and there are going to be risks, but the potential rewards are just, I don't know, they're just too big to ignore.
So where do we go from here? What are the next steps in this whole AI research agent journey?
Well, the researchers actually lay out a roadmap for future work in the paper, and it's all about expanding the capabilities of MLGym and other similar frameworks.
What kind of expansions are we talking about?
Well, for one, they need to add more diverse tasks to the benchmark. Right now, MLGym-Bench is mostly focused on, improving existing solutions, but to really push things forward, we need tasks that challenge the AI to come up with genuinely new ideas.
So more open-ended stuff like we were talking about before.
Exactly. And we also need better ways to evaluate those novel solutions. Right now, we rely a lot on metrics like accuracy and speed, but those don't always capture the whole picture, especially when it comes to these groundbreaking discoveries.
So we need a way to measure the aha moment, the spark of insight that leads to a paradigm shift.
Exactly. That's a much harder problem to solve. We might even need to involve human judgment in that evaluation process or come up with completely new metrics that can actually capture the essence of scientific creativity.
Okay, this is PhD level stuff. I feel like I need to go back to school.
You're not alone. This is a complex field and it's evolving so quickly. But that's what makes it so fascinating, right?
Yeah, it really is. Well, I think we've given our listeners a lot to chew on today. We've gone from this whole idea of AI research agents to this MLGym framework and even pondered, the philosophical implications of AI designing AI.
It's been quite the journey.
It has, and we've only just scratched the surface. AI research is moving so fast. Who knows what the next few years will bring?
It's going to be wild. I can't wait to see what happens.
Me too. But for now, I think it's time to wrap up this deep dive.
I agree.
So to all our listeners out there, thanks for joining us on the deep dive.